Hello everyone. We are from Gokaraju Rangaraju Institute of Engineering and Technologies from Department IT. We are going to present a mini project on next line prediction under the guidance of Dr. Akila ma'am, and our team members are Lokesh, Virat and Varaprasad. Let us look the contents involved in our project. These are the contents that are involved. And next line prediction. Pioneering intelligent text prediction for enhanced user experience is the outline of our project, and our domain is deep learning. Project develops an advanced next line prediction system using a hybrid approach. The core features are long short-term memory, neural network, and word embeddings. Our project builds upon advanced LSTM networks. This generates next words for an appropriate given sentence. This starts with word embeddings. This means converting the given words into dense vectors, and then there are two LSTM layers which converts the embeddings into sequence. Then the process goes on and it gives predictions to our required input. Existing system. There are many existing systems like to predict next word like excelnet and transformers, but these did not reach our expectations in predicting the next word. So we are going so we decided to do a project on next word predictor. These models are widely used in natural language processing tasks such as text completion, language translation, and dialogue systems. Proposed system. The proposed model for next line prediction builds upon advanced LSTM network. This generates next words for an appropriate given sentence. This starts with embeddings. This means converting the given words into dense vectors. And there are two stacked layers of LSTM, each consisting of 1000 units. First layer produces sequence of outputs, one for each time. These processes the word embeddings sequentially, and the second layer produces the final time steps. This captures the long short term dependencies and overall context of the entire input. Through this, it can able to predict the next word. Dense layer with ReLU activation. This dense layer learns complex pattern and interaction within the text and ReLU activation function. This enables the model to learn intricate relationships in data. So we can easily predict the next words with even if the user gives complex inputs. And training. Here the training is main base for our model. If the training is highly rich in data and more in diversity, then the user will get relevant output. The model is trained on a large corpus of text to learn various linguistic patterns and contexts. We have to train with different linguistic patterns and contexts, and we use a loss function as categorical cross entropy. This used to measure the difference between the predicted probability distribution and actual distribution. Our model uses iterative prediction. This means model predicts the next word based on the input sequence and then uses this prediction to generate subsequent words. And context relevance prediction also uses by our model. By considering both long-term and short-term dependencies, model generates text that is contextually relevant. And the purpose of our system. For purpose of creating this system is this helps in creative writing and academic writing. This assists researchers and students in drafting papers by suggesting relevant continuations. And this increases productivity, reduces time and effort needed to text, enhances creativity, provides creative prompts and unexpected continuations that can inspire new ideas and directions in writing. And the problems we are going to face is we have to collect large amount of data and that should be in diverse nature. The collected data should be relevant to the user. Fast predictions and accuracy means we have to give prediction fast and that prediction should be accurate. Literature survey. As we have studied literature survey different projects similar to our projects, there are different projects similar to our project. First one, Real Brewer. He says that various problems causes errors like errors in logic codes, etc. These may affect our output, project output. Software metrics like line of code and cyclomatic complexity often fail. So, we proposed a method that combines deep learning methods and word embeddings to predict the next word. Jonah JB. Limitations to form correct syntax if these takes less coaching time. He said the training time should be more. This indirectly means we have to train our model with large amount of data. So this gives relevant output. And NTK Nala. This is not easy for inflected languages like Simhala, which consists of complex grammar are rich in grammar. So we decided to predict our output in English. So we decided in English language to predict the next word from Aditya Tiwari. We came to know that it is helpful for many people like who doesn't know spellings, how to type, etc. This project is helpful for many people, not only for who students, etc. This is also helpful for common people also. Columbi Nora. She uses letter to letter prediction to build a word, but this letter to letter predictions takes lot of time to build a paragraph. So we decided to build a word to word prediction. To build this decreases time and increases productivity. We came to know that, but it works better than letter to letter prediction. Design of the project. This is the use case diagram of our project. First, the user has to open application. He has to input the text and enter number of words and submit the form of, and then he gets the result predicted text and the background operations like loading model and opening tokenizer, generating predictions and returning the prediction text. Activity diagram. First, user opens the application, user enters the input text, user enters the number of words, user submits the form, application receives input, application loads model and tokenizer, application generates predictions, application returns predicted text, application displays result to user. And this is class diagram and this is sequence diagram. and this is object diagram. This is component diagram of our project. This is deployment diagram. This is state diagram. System architecture. The user interface. First, user interacts with application. In that application, he gives input text, and he also gives the number of words required to predict. And the prediction function uses request prediction. Here the trained data used by the model to predict the next word, and this predicts the next word. Now let's see implementation of our project. Now I am giving here input, what are you, and I am giving here word count for line 9. Now click run code. Here is the output. We got, what are you going to keep married on eating meals honey? Simple. To get next prediction, we have to do the same thing again. Now I am giving it's nice as an input, and the word count is 5. Click run code. Here is the result. It's nice be the excellent circular handkerchief beyond. Click go back. These are the references of